Welcome to another chapter of SystemVerilog course. And in today's chapter, we are discussing of the most important concept of SystemVerilog, that is object-oriented programming. Now, because of this Verilog, we updated with OOPS, and we got our new languages SystemVerilog. So basic concepts are same as Verilog, but we have our OOPS concept, so we have multiple features added in our SystemVerilog. Now, before understanding what is SystemVerilog OOPS, we should understand what is object-oriented programming first. So object-oriented programming style where we create object, instance or classes, okay, that contain both data and properties and functions. So what we can see from this statement is that our object-oriented programming has classes, okay. So this classes is nothing but one of the block, just like your module, okay, just like your module we have our classes. So in classes is syntax is like class and class. For now there are name and everything, but for now you should understand that class and end class is similar to your module and module. Then what is the difference between classes and module? The major difference between those two are it is dynamic memory and it use static memory. Now whatever you write inside this will have dynamic memory, for example methods and your variables or properties. So in here also variable or property or our methods will have static memory, and here we will have dynamic memory. So this is the major difference between those two, and because it is synthesizable and it is not synthesizable, okay, so it is very appropriate for writing test benches, these classes. So you can have your here modular, reusable, maintainable and scalable kind of thing, means you can reuse everything because it has dynamic memory. In runtime also you can change everything, okay. So this is the main feature of our OOPS, okay. So OOPS has classes, and classes has you can have variables, methods and everything written inside that, and you can use it multiple times. So this is a basic definition of what is object oriented. Object is class creates object, and that object you can reuse in your module or anywhere, and in classes you can write your function as well as your method. Now some basic terms are there which I will be using in future, so you should know before that. So classes already I have told you, blueprint containing data and methods. So data and methods are contained inside your classes, which is our class, okay. Now object, instance of class. So for example this is our class, just like you have class A in any other languages, you will create an instance for this class A, then you will create A1 as an instance. So if this is class A's instance is A1, so it is pointing towards your class A, okay. So this type of thing, this is instance which we are taking one of the thing to point to our classes, which is created as an object, okay. So this A1 is an object of class A, okay. All the features of class A which we have written, methods and everything we can use in as A1. So this is instance of class. Now handle, variable that stores a reference address of an object, okay. So this is also called a handle, okay, this is also called an handle. What is object? We have created all these properties into one variable, that is called object. And what is this A1 is a handle of class A, new. It allocates the memory, okay. This new we have already studied this one, okay. So this one is for dynamic array, and this one is for construction or giving us storage for our objects, okay. It will give a memory allocation for this object. So what we will do, A1 equal to new, and we will write this statement. So A1, which is variable of object or class A, and which we will give a memory as a new, okay. This is our new property variable inside a class. So this is variable which I have already told you, which is also called as property. So variable inside the class is our property. Now methods are function and task, you already know about that one. Constructor, when we write function new, a constructor class where we will give memory allocation, and when something is created with some initializing with some function, then it is called a constructor. That function is called constructor, so it is basically function new. So this function we will write in every class, so which will give memory and everything related to our object-oriented programming when it initializes in compile time. Okay, so we will understand this in when we will create some classes. Extends. So when you use inheritance, this keyword will come extends. So we will also understand this in inheritance video, which will be next video. And then we will have that super keyword refer to a parent class to a constructor method. Okay, so this is a polymorphism concept which we will also cover in after the videos of inheritance. Then virtual is also polymorphism, we need this one, and this keyword refers to the current object. So whenever you write this dot a and equal to a, so this a can have int a, let's say, is written in this class or this object. So this a will say this a is this one which is inside the class, and this a is from the next class. Okay, it can be from class b, and this is from class a. Okay, so this object is from this class, so this will indicate whatever written in that scope. Whatever written in that scope, we will say this is, we will use this keyword when there are different handles with same name or something. Okay, so we will also see this one when we will go towards our object-oriented programming and solving some of the codes for this one. Now, why we use oops? Reusable is the main thing. Then make test bench modular and scalable. We can have very complex TV than our Verilog, and easily extend existing code in using inheritance. We can use multiple times whatever we are writing in our previous class. Supports constant randomization. So you have used that $u random, right? So we have a very proper and customized way of using random. We can also have our customized randomization control. We can have a control of randomization, we can say, in our SystemVerilog. Simplify, maintain and large verification environment. So we can have a complex environment because today's chips are too much complex, so we need something for that. And we also created UVM for similar thing, because SystemVerilog cannot handle that much of complex thing. Then we use UVM, which is more of a SV only, but using some methodology, means some process, or with you can say some things are created to our SV, some updates are there to our SV. That methodology is UVM. Okay, it is only a SV but little bit different from for writing style, so it is called as methodology, not a language. Okay, this is methodology, not a language. So SV is important to learn, then you can easily learn about UVM. Now we have 4 pillars of OOPS, right, which we will cover in our next videos. So first is our encapsulation. So combining data method into single unit and controlling access to them is our encapsulation. Encapsulation is nothing but when you cover one thing with another. So A and B. So A is covered by B. So encapsulate B is encapsulating B. So if you instance taken of B, you will not see A. So that A, because of encapsulation you cannot see, is abstraction. Okay, so these are connected things. So showing only the necessary functionality while hiding the implementation details. Okay, you can hide this A, and if you are seeing this A anyway, when you have one wrapper around A or any class,
hit subscribe, like and comment now. Let's begin the journey of verification.
So for example, which we have taken previously, like class B and class, and inside that you have written class A and class. So this is wrapper outside our class A. So this is nothing but our encapsulation. Okay, so protects data and keeps related functionality together. Okay, now we will see this when we are creating the test bench. Okay, and SV keywords class local protected can be used. Okay, now inheritance, which we will see in next video most probably. So inheritance, a child class inherits properties or methods of our parent class. So it is not similar to your inheritance in your real world, like your father will inherit, son will inherit all the property of your, you will inherit all the properties of your father. Okay, similar to that, methods also there. So for our coding perspective, properties and methods are both you will inherit it from your father. So similar to that, your son's son will also inherit this both this one as well as your property. You will have some own your property, okay, property and methods, so you will inherit both. But if you have some brother, okay, your brother is there, his brother is there, let's say, so your property will be also his and his property is also his. So in this way, some inheritance is similar to your real world scenarios of inheritance, which we will cover in next video with a code example. Now polymorphism. One interface, multiple implementation. A parent class handle can point to a child class object, allow flexible dynamic behavior, so this is keywords also have written here, which we will using in writing this all things. But for now, polymorphism, you can understand, like if there is a function a in parent class and in child class you have function b, a function a similar name, okay, so you can override this with your child class handle. This is polymorphism. So one class, one method a can be have different behavior, like in this you have write dollar display parent, and in this write your dollar display child. So you can print child as well as you can print your parent, okay. This both function can be used with different behavior with same name. So that is nothing but our polymorphism. Abstraction is data hiding. You can hide the data with the help of this virtual class, pure virtual class, and you can also have a protected kind of thing. We mostly not use this one, but it is automatically you are doing abstraction when you are doing encapsulation, okay. Now let's have a little bit summary. So encapsulation in bundle data method together, wrapping of the data. You can also say this one. Inheritance is when you inherit something from your father, you can understand with that example. Polymorphism, one class with different behavior. You can have a different behavior of similar functions or methods when you use our polymorphism, means you can use overriding in your polymorphism. So because of this overriding feature, we use our polymorphism, and it is created so that we can use overriding. Now abstraction is hiding of data. So you can have focus on this one or not, it is not important. The most important thing is these three things, and you can have this as your abstraction. In industry, they when your product based company is there and you are a contractor, they are using this abstraction, you will only see limited kind of things. Now easy way to remember is this bundle of everything, reusing the code, one handle many behavior, and hiding details, okay. So these are the four concept foundation of OOPS in SystemVerilog, are essential, or this is only the topics you needed to learn. In your interview you will be asked on this question. You can there may be the most possible way to ask is write a code for polymorphism or write a code for inheritance. These two concepts are most important in your interview perspective as well as your in career, okay. So thank you, we will meet in next video and we will complete inheritance.
Please Lord give me a sign, a sign.